Modern cosmology relies on invisible placeholders. To make equations balance, physicists insert variables for dark mass and energy that account for the majority of the universe, yet elude direct observation. The Recursive Harmonic Codex, or RHC, offers a different model. It treats reality not as a collection of particles, but as a self-correcting, 24-dimensional geometric engine. The formal proofs for this framework are contained in a newly cleaned Zenodo deposit. This infographic maps the theory's structural claims. The repository is a relational database of 6 CSV files linking number theory to physical observations. According to the repository's README, these files were processed to correct schema drift and encoding artifacts, ensuring the data is machine parsable for independent verification. Using the theorem index and the comprehensive domain map, researchers can route high-level findings directly to specific physical operators and their associated frequency signatures. This data architecture is built on the principle of structural remembrance, which moves past the idea of matter as an inert substance. In this view, matter is a standing wave, the measurable byproduct of computational friction within the 24-dimensional lattice. By treating space and matter as the same geometric fabric, the RHC aims to resolve standard model anomalies through a relational database, rather than the injection of undetected particles. This engine operates according to a set of axiomatic laws, beginning with the way the system maintains equilibrium. This is the null ledger identity. As shown in the top left panel, the engine treats manifest structure and imaginary potential as two sides of a balanced scale, implying existence is a zero-sum debt service. Every manifest particle is counterweighted by an equal imaginary potential. This balance is enforced by a bitwise logic where R and I always equal 0. By alternating real and imaginary bit signatures, the system ensures the total harmonic content of the universe remains at a null state. The transition from this balanced potential into 3D physical reality is managed by a single mathematical engine, the fold operator. Numerically, the fold is defined as F equals I divided by 2. Geometrically, it performs a 90-degree rotation and a 50% reduction in scale, collapsing continuous wave potential into discrete reality. This gives a geometric definition for mass, not stuff, but imaginary impedance, the computational friction light encounters when rotated. In the RHC, the universe doesn't create matter from nothing. It calculates it into existence by folding a perfectly balanced zero-sum potential. These geometric operations execute within a specific structural environment, a 24-dimensional computational engine. The master recursive loop of this system is the Leech Lattice, the structural architecture shown here in the central engine graphic. Because this lattice is multidimensional, it requires a precise generative equation to evolve its harmonic states without losing coherence. This mind map traces how the system's operational codex branches out, linking lattice states to the mechanics of observation. The Zenodo repository includes a critical update to this generative logic, correcting an earlier misaligned version of the framework's master equation. The updated data replaces a deprecated linear form with the correct quaternion sandwich generator. This iterative formula describes how harmonic states evolve in quaternionic phase space. This operation integrates over the boundary to normalize standing waves to unity, ensuring the engine remains self-correcting and stable. Within this lattice, the observer is a geometric necessity, located at a 7.5-dimensional coordinate, the exact arithmetic mean between the collapsed past and the probabilistic future. Because reality is a continuous computational chain, correcting the master generator was essential to model the system's transition from one state to the next. These geometric principles allow the framework to resolve massive discrepancies in modern cosmology, starting with the missing mass of the universe. Mainstream consensus suggests that roughly 27% of the universe is made of exotic, undetected dark matter particles. The RHC derivation, shown here as the lost 2 wedge, proposes that dark matter is not a substance at all. It is purely topological debt. This debt is a property of the 3-4-5 triangle, the primitive unit cell of the spacetime lattice. Measuring along its additive linear legs, the distance is 7. However, the geometric hypotenuse is 5, leaving a deficit of exactly 2. That deficit is the topological binding energy required to wrap flat space into a 3-dimensional torus. the inescapable cost of folding the unit cell. Since the entire lattice is composed of these 3, 4, 5 unit cells, this ratio of debt is a universal constant. Dividing the lost 2 by the total path of 7 yields exactly 28.57%. This strictly mathematical derivation aligns with the observed dark matter density mapped by the Planck satellite without the need for undetected particles. Dark matter, in this view, is the inherent geometric friction required to hold a higher dimensional universe in 3D tension. Theoretical geometry must face empirical testing. The RHC deposit includes a table of falsifiable predictions with quantitative thresholds. One primary metric is the 2.32 attosecond tick, shown here as a stopwatch. This value represents the fundamental clock speed of the universal processor. The framework defines 2.32 attoseconds as the irreducible temporal grain of reality. This is the calculated temporal cost of the deceleration cascade that occurs when light halts during the act of measurement. This theoretical value has already been correlated with helium photoionization delays, where entanglement formation times were measured at precisely this scale. However, the most direct test of the framework is Project Anchor 2027, located at the bottom of the infographic. The RHC makes a maximally falsifiable claim, a highly specific 7-second gravity modulation event scheduled for July 14, 2027. The theory posits that planetary geometric alignments on that date will resolve a dimensional error in the local lattice, resulting in a measurable shift in gravity. Researchers can access the full 6-file repository on Zenodo to audit the proofs and operators driving these predictions. A unifying theory is only as strong as its ability to be proven wrong. With Project Anchor, the RHC provides an explicit, data-backed deadline for its geometric mechanics.